Okay, so you've got water pouring into two tanks at different rates. Tank A already has 500 litres in it, and water is coming into the tank at 20 litres per minute. Tank B already has 200 litres in it, and water is entering tank B at 50 litres per minute. Now in this question, they have converted both those rates and starting points into two equations. For the internal, you'll need to be able to convert the writing into the two equations yourself. You need to be able to do that skill. So notice that the rate is written in front of the time, and we often call that the x variable because it goes along the x-axis, and then the starting amount of water is added, which is where it's going to cut the y-axis. So that's tank 1 starts at 500 litres, 20 litres a minute. Tank 2 starts at 200 and fills up at 50 litres per minute. And the question asks, at what point in time does the tanks have the same level of water in them? Well, the answer to that question is going to be the intersection of these two lines that I'm going to draw on this graph. I've chosen this problem to do because the scales don't go up evenly. Well, they do go up evenly, but they go up by different amounts in different directions. I've also chosen this problem to get you familiar with. You don't always have to have y and x as your variables. In this case, we've called it W for water and T for time. So starting with W1, to plot W1, and I suggest you also do this in the internal, off to the side somewhere, you just plot a few coordinates to get your head around where the line is going to go. So if I call this, I would normally call this X, but instead I'm going to call it T, and I'd put a few values in. I'm going to put 0, 4, 8 in. I'll start with those three, and maybe I'll put another one in soon. And then normally I'd put Y here, but instead I'm going to put W. At time 0, we know 0 times 20, we're going to have 500. At 4 minutes, 4 lots of 20 is 80 plus 500. 580. And then at 8 minutes, 20 lots of 8 is 160, and plus 500 is 660. Okay, plotting those 3 points. 0, 500. 4, 580. I'm just going to take a best guess. And then 8, 660. And all going to plan, I should wind up with a straight line. Oops. Try again. I might actually try putting in 14, and so seeing a 14 gives me 14's here, and seeing a 14 gives me 800, and then I'll just confirm. I don't think it is, because 2 lots of 14 is 28, 280. It's just under 500, so my just under 800 rather, so my graph's slightly too steep. slightly. Anyway, for now I'm going to move on and I'm going to look at this graph. 50t times plus 200. Okay, somewhere else on the paper, draw yourself another table. Okay, again, T, W. Definitely choose 0 to plot. This time I might plot 6 and 12. Space my plots out a bit more. I know at time 0 that I have 200 litres. At 6 minutes, 6 lots of 50 is 300. 300 plus 200, 500. At 12, that's 600 plus 200, 800. Correct. Here's 3 plots to point. 0, 200, 6, 500. These ones are easier to plot, aren't they? What might have been better for the first line I plotted is to choose a few more points that are actually on intersections and I wasn't guessing. 12, 800. There it is there. Okay, and now I'm going to put in a straight line, and 12, 800 is right on that spot there. Okay, so the solution to this problem is right there. Now that makes it difficult, doesn't it? Not on a coordinate. So, if I had a graphics calculator, I'd be very happy right now, because I could put this on the graphics calculator and get it to find that intersection. Refer to my video on how to use your graphics calculator. If not, maybe I could take a guess and say at about 10.5 minutes, right? 10.5 minutes is here, and then work out the corresponding level of water by putting 10.5 either into here or into here. Both should give you the same solution. Actually, that's one way to check it, isn't it? Put 10.5 in both of them and see if you get the same solution. Alternatively, I could use what we call simultaneous equations, and notice that both are equal to a level of water. Well, if I want them to equal to the same level of water, I would simply equate them to each other. 20t plus 500. At what time does it equal to 50t plus 200? Okay, I've just equated the two equations. Then I can shift some things around. Maybe shift the 20t onto the left, onto the right, and shift the 200 onto the left. Okay, that would give me 300 on the left, subtraction, and that would give me 30t on the right. Oh, can you see what the answer is going to be? 300 divided by 30 is actually 10, and the unit is minutes. So, in other words, I've drawn my orange line quite inaccurately, and I should have plotted an orange line. Well, I should have plotted some more points, and I would have had the right solution. Yeah. Okay, so lesson there for the teacher. Plot more points, do an accurate linear graph, and you won't be thinking the answer is 10.5 when it is actually 10. I encourage you to practice this idea of different sets of scales. You're possibly used to a scale that goes up in 1's in both directions, and let me tell you that will not be the case for the internal. You'll need to be familiar with how to deal with different scales on the different axes.